You know, I was reading this report the other day, and it said modern cities generate just terabytes of data every single hour.
Oh, the volume is staggering.
It's traffic sensors, air quality monitors, the swipe cards on the subway, even the GPS from our phones. We are absolutely swimming in information.
Hmm.
But here's the thing that drives me crazy. When a pipe bursts downtown or a new bike lane creates this massive gridlock, the people in charge, the mayors, city councilors, they often seem completely blindsided.
It creates this fascinating paradox, doesn't it? We have more raw data than at any point in human history, yet our decision-making often feels like it's, well, happening in the dark.
It's the whole data-rich, information-poor dilemma.
Hmm.
And it makes me think of that scene, in every disaster movie where the scientists run into the Oval Office with a stack of papers and the president just yells, "Speak English, damn it!"
That is actually a perfect summary of the crisis we're talking about today. We're currently stuck in what I like to call the technician's trap.
The technician's trap. Okay, that sounds like a bad escape room.
It kind of feels like one for urban planners.
Hmm.
The central tension is that for the last 20 years, urban planning tools have been built by the technician for the technician.
Right. By the experts for the experts.
Exactly. We focused entirely on gathering big data and building these incredibly complex mathematical models, but we forgot the most important part,
The translation.
the translation. We aren't communicating that data effectively to the people who actually sign the laws, who write the checks, or frankly, the people who live in these neighborhoods.
So we built these incredible smart cities, but the dashboard is so complicated, you basically need a PhD in data science just to figure out if it's going to rain.
Essentially, yeah. And that's where our deep dive starts today. We are looking at a project called DECIDE. It's this research through design initiative that just looked at this whole mess and said, we don't need more data, we need better translation.
Their mission statement really grabbed me. They aren't trying to build a better sensor. They're trying to fix the, quote, translation error between the data scientists and the decision makers. They want to move from smart cities.
Which is such a buzzword.
It is, from that to decoding the city.
Right. Because a smart city isn't very smart if the mayor can't understand what the city's telling her.
So let's dig into the status quo. I mean, why is it so bad right now? The sources you sent over describe the current landscape as a bit of an alphabet soup of strategies that are, well, they're failing us.
It really is a case of drowning in data but starving for insight. The traditional landscape is dominated by three main approaches. The first is what we call data-driven strategies, or DDS.
Okay, this is the hoarder approach, right? Just collect everything.
That's a harsh but a fair way to put it. The philosophy here is volume. Collect everything: traffic counts, census data, weather patterns. The assumption is that if we just have a big enough pile of data, the answers will magically reveal themselves.
Which, of course, they never do. It's like having a library with 10 million books but no card catalog and all the lights are off. I mean, the knowledge is in there somewhere, but good luck finding it.
And then you've got the model-driven strategies. This moves away from just collecting data to actually simulating it.
Simulations.
Right.
Yep.
We build these incredibly complex mathematical models that assume decision-making is this, rational linear process. We simulate traffic flows or economic shifts based on perfect logic.
But cities aren't logical. They're chaotic. A protest happens, a water main breaks, or everyone decides to drive to the beach on the same sunny day.
Yeah.
I mean, linear models just break down when real humans get involved.
That is the flaw. These traditional methods focus entirely on the input, how much data do we have, or the process, how fancy is our math.
Yeah.
They completely ignore the outcome.
Right.
So when a city councilor, who might be a former school teacher or a small business owner, not a data scientist, looks at a dashboard built with these strategies, they don't see insight. They see a terrifying wall of numbers.
And that leads to what the DECIDE report calls information loss. The policymaker gets overwhelmed, so they just, ignore the data and go with their gut?
Or worse, they misinterpret it and make a disastrous decision. Now, to be fair, there has been an attempt to fix this with something called knowledge-driven strategies.
Okay.
And this tries to tailor the information to experts.
Mm-hmm.
But think of a hospital.
Okay, I'm picturing a hospital.
You have a surgeon, a nurse, and a hospital administrator. They all need data about a patient, but they need completely different things. The surgeon needs the MRI. The administrator needs to know the cost of the procedure.
Mm-hmm.
Knowledge-driven strategies tend to build a system for the surgeon and then just hand it to the administrator.
So the administrator is staring at a picture of a liver and trying to figure out how to budget for it. The data's technically accurate, but it's useless for the job they actually need to do?
That's the expert system limit. Urban planning is inherently interdisciplinary. You cannot solve a city's problems with just one perspective. A traffic engineer needs different information than a social worker. But if your system assumes everyone is an engineer, you fail the social worker.
This is where DECIDE just flips the script. They introduced a new framework called Outcome-Driven Strategy, or ODS. And this feels like a really fundamental shift in philosophy.
It turns the whole process completely upside down. Instead of starting with what data do we have, the outcome-driven approach asks, what does the user need to understand?
Oh, okay.
It prioritizes the accessibility and interpretation of the result over the complexity of the model that's running behind it.
It sounds a lot like user experience design, or UX, like stop designing a remote control with 50 buttons when all I want to do is change the volume.
That's it, exactly. It draws heavily on this concept of universal design, the idea the system should be accessible to everyone, regardless of their technical literacy. It's about creating a fit-for-purpose approach.
So if I'm the mayor, the system knows I need the, executive summary version, but if I'm the head of the water department, I get the technical deep dive.
Same data, different story. And that story part is absolutely key. They didn't just write a manifesto about this. They built a prototype. It's called the DECIDE-DSS.
Right, the software.
It's an open source piece of software built on Python that actually demonstrates this whole outcome-driven approach.
And they use this term I found interesting, digital shadow. I know we usually hear digital twin, but shadow feels, I don't know, darker.
It's actually more pragmatic. A digital twin implies this perfect real-time replica of the entire city, which is incredibly expensive and honestly almost impossible to maintain.
Right.
A digital shadow is more focused. It's an integrated view using what they call multi-domain models. It pulls in data from OpenStreetMap, census bureaus, flood risk agencies, but it focuses on the interplay between them.
And this is where the tech gets really cool, because usually when you combine a map of roads and a map of flood risks, you just get a map with some blue blobs over the streets.
Right, and that's the technician's trap all over again. A blue blob tells a hydrologist water depth is 0.5 meters. But what does that tell a regular person?
That my feet will get wet.
Exactly. It doesn't tell them the consequence. The DECIDE-DSS uses what they call GeoAI to translate that. Let's look at the Cardiff case study from the project.
Cardiff, Wales. A rainy place. A very good place to test flood models.
So they combine the road network analysis with flood vulnerability data. But instead of just showing the water, the system calculates accessibility.
Okay, what does that mean?
It answers questions like, if this street floods, which hospital becomes unreachable? Which retirement home is cut off from emergency services?
See, that's the so what factor. A blue map is just data. Grandma can't get an ambulance is an outcome.
And to communicate that, they built in something called a narrative AI.
Oh, I love this feature. We're all used to dashboards with charts and graphs, but the system actually, well, it talks to you.
It uses AI to generate text summaries in plain English. So right alongside the map, you get a little window that says, warning, a flood event of this magnitude will isolate 2,000 residents in the Riverside District and increase ambulance response times by 15 minutes.
That's a game changer. It completely democratizes the data. You don't need to know how to read a topography map to understand that people are in real danger.
It removes all the ambiguity. And this brings us to the most innovative and honestly the most risky part of their whole project. How do you even build a system like this?
You'd hold focus groups, right?
Usually, yeah. You'd get the mayor, the engineers, and some citizens in a room and ask them what they want.
But have you ever tried to get a city councilor, a CEO, and a busy parent into a room for a 3-hour workshop? It's impossible.
It's the biggest bottleneck in this kind of software development. Stakeholder fatigue. You just can't get on their calendar. So the DECIDE team did something wild.
What's that?
They used AI to design the AI.
Okay, now this is the part that sounds like science fiction. They used large language models, the same tech behind things like ChatGPT, to create AI user personas.
They essentially cloned their stakeholders. They created a virtual counselor, a virtual technician, and a virtual community member.
Okay, I have to play devil's advocate here for a second. Isn't that just a recipe for hallucination? You're asking a computer to guess what a human wants. How do you know the virtual counselor isn't just making up problems that don't even exist?
That was my first thought, too. But think about how these models work. They're trained on these vast amounts of text interviews, policy papers, community complaints, meeting minutes.
So they have a good idea of the language.
They have a pretty good statistical grasp of what a frustrated bureaucrat actually sounds like.
So they prompted the AI to act like a counselor using this new software.
Yes. They simulated what they called user journeys. They'd present the AI counselor with a prototype of the dashboard and just ask, what is frustrating you right now? And the AI would come back with things like, I don't understand what this risk index means, or I need to be able to export this as a PDF for my meeting on Tuesday.
That is scarily accurate. The export to PDF demand is the most realistic thing I've ever heard a computer say.
It allowed them to do agile development.
Right.
They could iterate on the software literally overnight based on the AI's feedback, rather than waiting 6 months for a town hall meeting.
But you still have to verify. I mean, did they ever check if the AI was right?
They did. And this is the crucial validation step. After they built the system using all this AI feedback, they ran a survey with over 100 real humans. They compared the real feedback to the AI's feedback.
What happened?
The correlation was incredibly high. The AI personas had accurately predicted the specific pain points and the needs of the real people. It proved that this kind of supervised Gen AI can be a valid proxy for stakeholder engagement when you're stuck in that development bottleneck.
That's a massive efficiency hack. It means you can do the universal design legwork before you even bother the real humans.
It lets you come to the first real meeting with a product that already works, instead of just a blank whiteboard.
So we've got the outcome-driven theory, we have the GeoAI software, and this AI-driven development process. But where does the rubber meet the road? You mentioned Cardiff, but this wasn't just a UK thing, was it?
No, the impact is global. They ran pilot studies in Porto Alegre, Brazil, looking at flood risks and network performance. They had spin-offs in Bristol looking at e-scooters.
Oh, e-scooters, the most controversial topic in all of urban planning.
It's a perfect test case for these multi-domain models.
Yeah.
You have to balance traffic flow, pedestrian safety, the actual availability of the scooters. It's a total mess of data layers. But the outcome-driven approach helps distill all that into one question. Where are the conflict zones?
And I noticed in the notes that this project won the Alliance Climate Risk Award. That feels pretty significant.
It's huge, because who cares more about risk than an insurance company?
Exactly. If I'm Alliance, I'm not funding this for charity. I'm funding it because if a city doesn't understand its own flood risks, I'm the one who's going to lose $1 billion in claims.
That commercial validation changes the entire conversation. It shows that identifying these fragility points in the city's network isn't just an academic exercise. It has real financial value. If this tool can show an insurer exactly which road intersection is the single point of failure for an entire neighborhood, that completely changes how they insure that area.
It connects right back to that digital shadow idea. If the shadow shows a break in the network, you can fix it in the real world before the disaster actually happens.
And that leads to the broader societal impact. We often talk about making data fair, findable, accessible, interoperable, and reusable. But DECIDE argues we need to add understandable to that list.
Because if it's not understandable, it's not transparent. And if it's not transparent, nobody's going to trust it.
Trust is the currency of urban planning.
Yeah.
We're seeing this shift away from black box models, where you feed data in and some mystery answer comes out, to glass box models. If a community can read that narrative AI explanation and understand why a road is being closed or why a flood wall is being built there, they are much more likely to support it.
It empowers the citizen. Instead of just being told the computer says no, they can see the reasoning. The computer says no because if we build here, the fire truck can't get to the school.
That is the absolute essence of democratizing urban planning.
So let's wrap this up. We started with the exhausted mayor staring at a screen full of gibberish. Where do we go from here?
I think the lesson from DECIDE is that we need to stop obsessing over the volume of our data and start obsessing over the communication of it. We're moving from the age of big data to the age of communicated knowledge.
It's a real call to action for anyone listening who works with data, whether you're running a city, a business, or just a fantasy football league. Stop building dashboards for yourself.
Build them for the person who has to make the decision. Ask yourself, does this outcome empower them to act, or does it just impress them with how much math I know?
I want to leave everyone with a thought to chew on. We often assume that as technology gets better, it gets more complex, higher resolution, more variables, deeper simulations. But maybe true technological advancement is the exact opposite. Maybe the most advanced city model isn't the one that simulates every single raindrop. Maybe it's the one that can look a regular citizen in the eye and explain in plain English, here's what this means for you.
Complexity is easy. Simplicity and clarity, that's the hardest engineering challenge of all.
Thanks for decoding the city with us today.
Always a pleasure.
Catch you on the next deep dive.